All right, this is a video for geometry on the volume of pyramids and cones, and we'll start off with a pretty straightforward formula and then just apply that formula with a few different solved examples. So both pyramids and cones have the identical equation to find the volume, okay, or the identical formula. So we can use one formula. Volume is equal to 1/3 times the area of the base times the height. Okay, and a little bit of notation right there, that capital A with a subscript B, I'm just using that to refer to the area of the base. And the height needs to be the perpendicular height, the distance from the vertex that perpendicularly meets the base. So in other words, not the slant height. I'm going to highlight in red here the slant height for this cone and this pyramid, and that's not what we're working with in this formula. We need the perpendicular height. And then times a third. Okay, hopefully you can imagine that if we didn't have that 1/3 right here, we would just be finding the volume of sort of the associated prism. But you can imagine that that pyramid or the cone would have a lower volume because the faces taper into a point. So we do need that 1/3 in there. It's actually quite a tricky challenge to determine where that 1/3 comes from, and I encourage you to investigate that one on your own. Okay, so let's look at a real world. This is the famous glass pyramid designed by I.M. Pei at the Louvre Museum in Paris. And it's a square pyramid with a side length of its base of 35.4 meters and a perpendicular height of 21.64. So that height is the distance from the vertex sort of perpendicularly down to a point in the middle of that square. So let's find the volume of it. So the volume is 1/3 times the area of the base, which is 35.4 squared, times the perpendicular height, which is 21.64. Okay, so then it just turns into a calculator problem. Maybe as a minor efficiency tip, rather than typing in 1/3 or 0.3333, just divide by 3 at the very end. It might save you a couple keystrokes, a little bit of time. And so I get a final answer here of 9,039.46, and that's going to be in cubic meters. Okay, so just over 9,000 cubic meters would be the volume of that pyramid. Here's another one that's a little bit more complex because I'm giving you the slant height, I'm not giving you the perpendicular height. So sometimes it's really helpful to draw a sketch here, and I won't draw a perfect sketch, but I'll do my best. If we have a square pyramid that has a square base with sides of 40, I hope you can see that this perpendicular height which we're given, which is 25, is actually the hypotenuse of a triangle whose sides we could figure out. Okay, the base of that triangle is going to be 20. It's going to be half of that 40. Okay, and we are looking for h. So we can use the Pythagorean theorem here, and so we can say h squared plus 20 squared equals 25 squared. And if you're clever and thinking, keeping your brain turned on, you might realize this is a scaled up version of a 3, 4, 5 triangle. H is going to be 15, but let's go through the math just to convince ourselves. Subtract 400 from both sides, and then we can square root to find h, and we do get h is 15. So my perpendicular height is 15, and so now we have everything we need to know. So the volume is going to be 1/3 times the area of the base, which is 40 squared, times the height of 15. Feel free to try a little mental math. 1/3 times 15 gives you a 5. So we just, in our calculator, let's do 40 squared times 5. And I get 8,000 cubic meters. All right, another problem here. Let's start working with a cone, which basically a circular pyramid. Base diameter is 14, and the perpendicular height is 12. Okay, so once again, as I've been saying, the volume is 1/3 times the area of the base times the height. Okay, So this is going to be 1/3. The area of the base is pi times 7 squared. Hopefully you're seeing that the radius is half of 14. Okay, we need the radius squared to find the area of that circle. And then the height is going to be 12. So just to be clear, we have a cone that we're working with a radius of 7 and a perpendicular height of 12. Okay, so again, a little mental math efficiency step. Let's turn that into a 4 right away. And so we get 4 times 49 pi. 49 is the 7 squared. And so that gives me 196 pi would be the exact volume. And the approximate volume would be 615.75 cubic feet. Okay, so either of those would be valid answers right there. For an oblique cone, it doesn't matter that the vertex is not centered directly over the center of the base. We're still going to use the exact same formula. Okay, so the volume here is going to be the area of the base, which is, well, let's put in the 1/3, times the area of the base, which is pi times 15 squared. Remember, we want to use half of that diameter to get a 15, times 25, which is the perpendicular height. Okay, and I'll just go to my calculator to do that. So I get 1875 pi, which is approximately equal to 5,890.49, and this would be cubic feet. Okay. So 1/3 area of the base times the height, volume of a cone or volume of a pyramid. And that's a great place to stop.